So previously we started looking at projectiles and we looked at type 1 projectiles. So now let's look at type 2 projectiles. And really, if you can do type 1, type 2 isn't that much different. So we're going to start looking at type 2 projectiles. Now, a type 1 projectile was something like this, going straight off and then coming down, something like that. Type 2 is a little bit different, but really it's not. If you can do type 1, type 2 is no problem. So we're going to go back to the simulation thing we had before, and we will look what a type 2 projectile is like. So this is a type 2 projectile situation. So very similar, the same simulation we used last time. But if you notice, the cannon is now on the ground and it sort of shoots up. And this is a basic type 2 projectile question. So let's fire it. Come on, fire. Why I wanted fire. There we go. Okay, so there we go. So firing something like that. So that is a type 2 situation. So instead of just going straight off and then hitting the ground, it's starting at the ground, it's going up and then coming back down. So relatively straightforward, so no big deal. All right, now a couple really important things kick in with this that makes it just really easy if you know how to do type 1s. You notice there's that little green dot at the very, very top. There's a little green dot right where it hits like the maximum height possible. And if you notice, what's happening on the left of the dot and what's happening on the right half of the dot is perfectly equal, like it's perfectly symmetrical in every way. So it sort of looks like there's two parts, but I mean, there are two parts to the situation, but the two parts are perfectly equal to each other. So if you solve for one side, you've also sort of solved for the other side. And if we actually just limit this a little bit, if you just go to the green dot and just look towards the right, what is occurring towards the right should be really familiar to you because, well, here, let's see if we can fire it, and let's see if we can get it to stop at the top there. Okay, so there it is at the very, very, very top. And if I look what the cannonball is doing right now, I can bring in a velocity vector. And if I bring in the velocity vector, oops, there we go, you can see at the very, very top, the ball is actually going straight forward. Well, so right now the ball is off the ground, the cannonball is off the ground, and it's going straight to the right, and then it's going to hit the ground. Well, that's just a type 1 question. So this is one of the keys for type 2 projectile questions. It's just a type 1 from the top to the right, and since they're so symmetrical, it's just the same type 1 in reverse going to the left. So a type 2 is actually just made up of two type 1s, except the first part is just in reverse. So if you can do a type 1 question, there's typically no reason why you can't do a type 2 question because it's the exact same ideas except doubled, basically. Okay, so let's sort of go back to the other screen and sort of map this out for a type 2 question. So a type 1 question, we had that. So a type 2 question, is basically, shooting like this, going up like this, and coming back down. So if we look at type 2 projectile questions, the initial height is going to be equal to 0, and the initial angle is not going to be equal to 0. And that's basically what I like to call type 2. And like we said before, the key is to cut it up right in the middle there. That's where we like to divide it. And basically we have our two type 1s is basically what we have. So, and it's nice because we have like perfect symmetry. Now, we're not including drag, air resistance, any of that kind of crap because that would take away from the symmetry. This is all we're doing. So we got perfect symmetry. So it's sort of like you basically solve for one half and carry stuff to the second half, and that's it. Okay. Now, we still have the same types of quantities. A couple things are different here and there. Some of the key differences would be here. The velocity, in type 1, the velocity was sideways. Here it's at an angle. So we need to find out what is Vx and what is Vy. We've got to break apart the V there. Aside from that, the other difference sometimes is, we can find like the maximum height. That's, how high it goes. That's a little bit different. Sort of like the initial height in the other one, but same type of thing. But aside from that, it's the same type of calculations and measurements and that type of stuff. There's no real difference between the two. Okay, so again, best way to go through this is just to take a question and let's just solve for all the different things. All right, so here we'll take something really simple. Okay, a person here, or we'll use a cannon. We had a cannon in the simulation. There we go. There's the cannonball, something like that. All right, there we go, something like that. Okay, and so let's say, and we'll just start like initial stuff and just work through the scenario. So let's say this cannonball was shot at 30 meters per second at 40 degrees. And let's just solve for everything there. It comes back down. Now, one of the easiest things about these ones right here, one of the easiest things by far is the final velocity, because the final velocity over here is actually going to be the exact same thing as the initial velocity, except the angle is flipped, so that's super easy peasy. But let's just go back to the beginning and work through things. So the first thing I'm going to do is I got to break apart my v's, because remember we want to keep x and y stuff separate. So I got to find the x component and the y component for my velocity. So if I do the x component, I've got, I'm just going to round up quite a bit. Like we'll say 23 meters per second is my vx, and my vy is, was 23.0, 19.3 meters per second for my vy. So that's where we got to start first. So each one of these things is used for different types of quantities. And if you remember, it's the time that really connects the two together. Now I'm going to have my cannonball, and I can, I'm going to have it go up. So I'm going to look at some of the up stuff. So Vx has nothing to do with this. The Vy is the up stuff. So I know my Vy in the vertical direction, and it starts at 19.3. And I know at the top here, at the very, very top, my Vy is equal to 0 because it's going perfectly flat at the top. So for Vy, it goes from 19 and it goes up to 0. I know the acceleration vertical. I can use that to find the time. The same way we found the time in type 1, we would drop things straight down. We could find the time using VAT. I can do the exact same thing on the way up in a type 2. So to find the time, that's going to be my change in Vy divided by my gravity. So I can just take that 19.3 and divide that by acceleration from gravity, and let's round off. We'll say it's 2 seconds. Now I've got to be careful because that is 2 seconds on the way up to the top, which means it would also be 2 seconds on the way down. So that's my time up. So that's not my total time. So my total time, I often call it my time of flight, would then just be 4 seconds. And there's my total time altogether. All right. Anything else I can find out? Yes, I can find my height on the way up. I can find my distance on the way up. And it's similar to what we did before. We had, the height was 1/2 AT squared, dropping something straight down to find time. Well, I can do that too. I can do, my height would be my 1/2 AT squared. Just be careful, you only use the time on the way up. You only want to use the 2, not the 4. So if I do the 0.5 times 9.81 times the 2 squared, we're looking around, well, I'll round off again, it's around 20 meters. So this thing went 20 meters high. So that is my maximum height right there, would be 20 meters. So the same way in type 1s, we used the h equals 1/2 gt squared. If you know the height of the cliff to find the time, now you can use the time to find out the height that it went up to, which of course is also how far it's going to drop. Okay, so I've got my Vx, I've got my Vy, I've got my total time, I've got my distance up. Really the only thing left would be the sideways distance or the range. So if I find the range, remember that's a Vx thing, it's basically dtv again, no difference. And what some people do is they'll solve for the range for the first part or the second part and then just double it because it's symmetrical. I typically just double my times because for my time, I would want to use my time of flight, my total time, because it's always moving the x direction in the same direction. So if I do that 4 seconds, I'll do the 4 seconds for my total time, times my Vx that I had at the beginning, which is like 23. I've got a range of 92 meters. So there's the total range for my projectile. So again, it's pretty much the exact same thing as a type 1, just got to double a couple things here and there, and that's it. All right, so let's try another question as well and go through it. And once again, no new calculations, just different application of the same material. Okay, so let's see, we got, I'll draw some ground here. All right, so draw some ground. All right, over here, we're going to draw, let's see if I can draw this. Now we got a little frog, something like this. All right, got a little frog over here, and our frog is going to jump, and our frog is going to jump up and come down, something like this. And let's say the frog, we'll say some kind of crazy super frog. The frog ends up going 18 meters high, and let's say it lands 50 meters away. So whatever, some kind of crazy super frog. And what I want to know is what was the initial velocity it jumped at. Okay, so again, let's just look what we got. What can we piece together? So I got the range and I got the height. So for the two, I'll start with the 18. I'll use the height because with that height that I have, that 18 right there, I can find the time it took to come down. Okay, so if I do the maximum height is equal to 1/2 gt squared, this would be the time to go up or down. It doesn't make any difference. I can find out sort of like my half time. Okay. Now make sure you don't forget to square root the t afterwards when you solve it. But it looks like around 1.9 seconds. So 1.9 seconds to go up and down because, of course, it's symmetrical and just easy peasy then. So my time of flight would then be 3.8 seconds. Okay, so now I have that. Well, I can use my time up or down. I can use that 1.9 seconds to find out what my Vy must have been. So my change in Vy would be GT, and use time up, time down. It doesn't make any difference. Just use the 1.9, not the 3.8. So if I take that time and I multiply it by gravity, I've got a Vy of around 18.8 meters per second. All right, so I got my Vy. So to find my initial velocity, I need my Vy and my Vx. I've used my height and my time to find out my Vy. All right, so now let's find the Vx. Okay, so to find the Vx, the sideways stuff, I can use my 50. That's my range right there. So my Vx would just be dTV, my range divided by my time of flight, my total time, because of course it's always moving in the x direction. So if I take my range, if I take my 50, and I divide that by the 3.8, my total time, I will get a Vx of around 13.2 meters per second. Okay, all right, well, I've got my two V's. Now I just got to piece them together. So when I took off, I've got 13.2 sideways. I've got 18.8 going up. So I can use those to solve for my takeoff velocity for my froggy and polish it off. So I'll use a little Pythagoras. We get an overall velocity of 23, and then we'll do a little trig to get the angle in there, more than 45. So we punch that out, we get around 55 degrees. All right, so that would tell me that the initial velocity of my frog was 23 meters per second at 55 degrees. So that was his takeoff V. Okay, so that's type 2. So again, if you do type 1, it's all the same. There's no new formulas. There's no real new ideas. It's just slightly different viewpoint, and that's pretty much it for type 2 basic projectiles. Really simple. Okay, so again, just comes with practice. There's only so many scenarios, but dTV, VAT, the 1/2 AT squared. Again, a couple of key differences is, sometimes having to break apart V's at the beginning, maybe a maximum height calculation, but other than that, it's the same type of thing as type 1, not too different.